All right, so let's get this started. Welcome back to another live stream where we talk a little bit about ARM templates. And today we cover a very nice topic, at least that's what I think, which is deployment scripts. Now, before we start, just to let you know, deployment scripts is, well, a pretty new investment into ARM templates, and it is still in preview. So don't go back to your production environments right after this live stream and try it out. Well, try it out, but not in your production environment, of course. So use your test environments to play with that technology a little bit, because it's pretty much powerful. And the second thing I want to mention is, because it's still in preview, it's also not available in all the Azure regions. So there's still several Azure regions around that do not support deployment scripts yet. So just in case that doesn't work for you, check out if you're actually using one of the supported environments. All right. Let's quickly introduce ourselves. Martin, do you want to go first?
Okay, yeah. So my name is Martin Ehrnst, and I work for a service provider out in Norway called Intility. So we basically run the entire operation for most of our customers, both on premises in our own cloud and in Azure. I am running the Azure user group here in Norway and do some occasional skiing and race car driving. That's the quick introduction about me. Marcel?
Thank you so much. Yeah, my name is Marcel. I work for SoftwareOne, and together with my team, we help customers with everything Azure and M365. I operate out of Switzerland, and yeah, I speak a lot at conferences, at events, and now these days a little bit more at online events, and like to share my experience that I made with Azure and those technologies to make sure that you don't experience the same pitfalls that I did. And beside of that, I also organized 2 conferences myself with my team, which is Experts Live Europe and Experts Live Switzerland, to conferences where we bring together the community to learn, connect, and share, yeah, and have a great time. All right, as I already mentioned in the intro, this is another live stream of a full series of a total of 4 live streams, and I just want to quickly announce the live stream of next week, which will be, unfortunately, already the last one. Well, maybe we can still talk about extending this, but for now it's the last stream that we planned. So next week we will talk about code release using pipelines. So we'll show how to have approaches to release your code in a very structured way using a pipelined approach. And if you missed the other live streams, check out this URL. This will bring you to an article that contains the links to all the other live streams that have been recorded. All right, so what's on the agenda today? As I mentioned, we talk about deployment scripts, and we want to understand why those are needed. And for that, we will quickly dive into the limitations or the shortcomings of classic ARM templates, because maybe you experienced yourself already that you cannot do everything using ARM templates. There's limits. And this is exactly where deployment scripts come into play, because they actually fill the gaps where we just well cannot get to our goal by using plain ARM template code. So first we talk a little bit about limits, and then we mainly focus on solutions using deployment scripts. All right, so what's the limits of classic ARM templates? Before we actually dive into the limits, I want to quickly recap something I already shared in one of the very first live streams. If we talk about infrastructure as code, there's in general, there's two different approaches. So we understand and we know the so-called imperative approach and the declarative approach. And what's the difference? The difference is in an imperative approach, you have your code, and in that code, you actually define what should be changed. So if you take this example of the PowerShell script, you know that if you have a multi-line PowerShell script, every single line does something, and you instruct what needs to be changed. So line 1, do this, line 2, do this, line 3, do this, and then the script is done. Whereas the declarative approach is a little bit different, because you don't code what should be changed, but you code what the end result should look like. So you don't care about how it's done, but what you want. And this is what actually ARM templates are focused on, using a declarative approach where you describe your service and the components of your service, but how it's done at the end is not your business, because Azure will take care of deploying and configuring everything the way that is needed to make your described service appear in the Azure platform. So imperative versus declarative. Now, if we take a look at ARM templates, that declarative approach that we can use, it comes with some downsides, because, as I mentioned, we just cannot do everything. ARM templates are mainly there for, well, describing our services from a management plane perspective. So you can describe, for instance, your web application that might consist of a web app as well as a SQL server and a SQL database. And you can have several configurations, but you cannot configure that full application, depending on your exact needs, of course, because we only have very, very limited, if any, access to the data plane of our services. So imagine, for instance, a storage account. If you deploy a storage account, that's fine. You can control that with ARM templates. But then if you need to populate that storage account with data that is coming from on-premises, from the internet, from the cloud somewhere, this cannot be done with an ARM template, right? Or a second example, maybe your service needs a user account or something, or needs someone to be added to an Azure AD group. And again, this cannot be done using an ARM template, so it's not possible. Or as you can see, the third example, maybe you even want to communicate with an external system because you need to query something, right? You have kind of a lookup, and depending on the result, you then steer your ARM template deployment into a different direction, right? Also cannot be done. It's very hard. And this is what we summarize as the so-called last mile configuration. So because ARM templates might not be enough to really fully configure your service, we need that last mile configuration, and this is exactly where deployment scripts might be a good addition to your ARM templates. So what are deployment scripts? Deployment scripts are actually imperative scripts. And these imperative scripts, at least today, can be PowerShell scripts or Azure CLI scripts, depending on your needs, right? And the great thing is that these deployment scripts can be triggered directly from an ARM template. So that means you have your declarative code, but then inside your declarative code, you can also trigger scripts that are then adding some, let's say, imperative logic to the show, right? And for that, as you can see here, is that we have a new resource type that we need for that, which is Microsoft.resources/deployment scripts. And with that, we can actually trigger a script. And there's two ways to somehow activate a script. Scripts can be embedded in the code, or they can just be triggered by using a URI. So either the scripts can be embedded inside your ARM template, or you can just reference to the script by using a URI. This is what we call external scripts, which adds a little bit more flexibility because it allows you to test your scripts much better if they are stored externally. And also your code might be much cleaner if you don't store your imperative code inside your ARM template. But that's up to you. Maybe first it's easier if you start with embedded scripts, if you start playing with it, and then maybe later change to external scripts. All right, but now, how is that actually done? How is this working? So before we can use deployment scripts, we need an identity that will actually trigger and execute our scripts. And for that, we need to create a user-managed identity in our Azure environment. So a user-managed identity is a resource that you can deploy, and actually it will provision a service principal inside Azure Active Directory. And this service principal can then get specific permissions. So based on the script that you want to or need to execute, you of course need to assign this identity the proper permissions so that it doesn't fail later, right? And then you can have your script and let it run using this identity. All right, now, where does the script actually run? So if, we will see it later in the demo, but if you have a deployment script in your ARM template, what will happen is you will see that deployment script resource is deployed to your Azure platform. That's this first screenshot here. And it's a very, let's say, simple resource that stays there to represent your script. But it has a very important job because it governs the rest of the deployment process of your script. Because what actually happens, this deployment script resource will then be responsible for deploying two other resources. One of them is a storage account. So a storage account is deployed, and this storage account will be used to actually host your script. That's the second screenshot here. As you can see, I have a file share with a folder, and in there you can see that my script has been copied in there, which is myscript01.ps1. The storage account can be created as needed, or if you prefer to use an existing storage account, which is also a very valid option, you can also configure your deployment script resource to use an existing storage account, which personally I prefer because of one simple reason. I'm a super structured guy, and as you can see, the name of this storage account is, well, kind of randomly created, and I want to make sure that all of my resources follow a strict naming concept, and this is why I personally prefer to use an existing storage account, because then you can create it first and then just instruct your deployment script to use that existing storage account. All right, so storage account is now created, the script is copied in there, and then there's a second resource, which is even more important, which is a container instance that is created. Now, what does that mean? That means that at the very end, your script is executed in a container on the Azure platform. And it uses ACI, which is the Azure Container Instance, to start up a container. That container will use an image from the MCR, so the Microsoft Container Registry. Depending on if you're actually using a PowerShell script or an Azure CLI script, it uses like one or the other image, right? You can also control that. And then that container has then a mounted persistent storage area, which is the storage account that has been created. So you can see in the screenshot at the very bottom, you can see what it will actually trigger. So it mounts that that storage account, and the file script will be used as the container process that will be actually triggered when the container starts. So that means storage account is created, the script is copied in there, a container is spinned up, which then has a process that will just start that, in this case, the PowerShell script or the CLI script that lives in this in the storage account. And then that's already it. So that's the very short version how deployment scripts work. All right, so let's have a look how this looks like in Martin's demo. Martin.
Yeah, thank you. So let me pull up my screen. So the first thing that Marcel was referring to was the identity that we need to deploy, or the identity that is responsible for running the scripts. At the moment, that is using a service called Managed Identities, and a particular one called User Managed Identity. We could talk a lot about Managed Identity, but the important thing there is that the Azure platform will take care of the identity for you, so it will rotate secrets and that kind of stuff. What you need to do then is to create one of these managed identities, and then you will need to add that to your subscription or your resource group, whatever your scope of the deployment is. So I've already done this by, or you can see if I have done it. So under the access control, I will see that my managed identity is a contributor on my subscription. Then we'll need to go into the script itself and then use that identity. So it is a identity property settings, and we have to reference the whole ID, the resource ID of the managed identity itself. After that is done, the script will probably run. So the first thing I want to show you is the inline script approach. Like Marcel said, that you can run scripts inline, or you can reference scripts that you have online, for example, or in a repository or storage account somewhere. For inline script, I would only recommend that when you are using like a small script. So I created the smallest script that you can do here is just write a string and output the string within the runtime. And also what Marcel was referring to is the actual infrastructure that is being provisioned when we run the script itself, or the resource that it actually is. So the resource type of deployment scripts will deploy a storage account and a container registry to run your script. And you can control I heard that Marcel said that he wanted to have a strict naming policy, and of course you can run a storage account that already exists, but I wouldn't recommend that you run a storage account that you use for something else in case you actually configure this script to delete the infrastructure later. But you can, of course, use things that we have covered before to comply with your naming policy. So you can use regular functions to actually name the infrastructures that are being deployed, the storage account and the container group stuff. This is where you do this. So, for example, my container will just be called deployment scripts in this case, and I've set it to run Azure PowerShell 3.0, or you can run it Azure CLI. That is totally up to you. Then we have a few other settings showing here. There's which we'll probably cover in a later demo now, but you have a timeout on the script execution and also some cleanup preferences that we will talk a little bit about. So we are continuing with from our previous streams that is that we deploy storage account, and then in one of our previous demos, I copied one of our previous demos and I've added in the new resource, which is the deployment script. It will depend on the storage account container in this case. So it will first provision a storage account and then it will run the deployment script deployment itself. I can fire it off and we can quickly jump into the Azure portal and see that it actually is deploying our backend, so to speak, resources. And while we wait for it, we can see how it actually looks within the deployment here. So it's a regular ARM deployment with multiple resources. So it has storage account deployment and it has deployment script deployment, which is running now. And then it should have started to deploy the resources it needs to run our script. So this is the storage account that it uses for the scripts. And if the Azure portal can stop caching my stuff, there we have the container instance and the actual deployment script itself. So we already run and deleted it. So depending on the script, it will execute fast, and I have set my resource. I have set my configuration so it will delete the backend resources once it completes the scripts. So here you can see that it outputs what was set in the inline script. So hello from Azure deployment script, and you can see the configuration that we set as well. So cleanup preferences was set to on success, and an expiration time that we will cover a little bit later. In the next demo, we will probably have the time to actually see all the deployments that are occurring in the backend, because now it's already deleted by the ARM itself. Anything else you wanted me to cover in the first demo, Marcel?
I think that's more or less what we discussed, right?
Yeah.
So that's perfectly fine.
Okay, cool.
All right, cool. Thanks for that demo. So let me bring back my screen. Oops, that's totally wrong. Sorry for that. All right, I'm having some difficulties sharing my screen. Just give me a second. I hope that will do it.
We're back now.
All right, cool. Good. So we've seen how this works. So Martin showed you how that user managed identity is created, how he gave access to that security principle, so that I can actually create different resources and execute a script. That's very important. And we have also seen that, well, obviously the storage account, as well as that container instance, only existed for a very short time. And why is that? Simple answer, because once the script is executed, those resources are not needed anymore. So that container is really only spinned up to execute the script, and then it's again deleted. The same is true if you have a storage account that is automatically provisioned, not if you use an existing one, but if you have one that's automatically provisioned, then that storage account is again deleted because it's not needed anymore. And the deployment script, we've seen that, stayed around. That was not deleted immediately, but after a while, this would also be deleted from the platform. So that means all of these are temporary resources that are just provisioned and used for like a very short time frame. And the exact behavior, how these resources are cleaned up, that's up to you. So you can control how the cleanup process should actually work. And you can see that cleanup preference that Martin showed in his code can be set to either on success, which means if the script execution was successful and everything was fine, then it's not needed anymore. Then let's please just delete everything in one go. That's fine. But that means if your script has some issues or if your code is just not working as expected, those resources will stay around, and of course they can create like a big mess. So then it's up to you, for instance, to select always, which means it's cleaned up even if the scripts didn't run as expected. Or you could also set an expiration time where you can yourself control how long these resources should stay around. So these settings are available, and you have to, or you can add it to your code to control the cleanup behavior. All right, now what's also important is that a deployment script is, I mean, it's kind of a special resource type, but it's still a resource, and every resource can have return values. So now, in the demo we've seen, it just created a write output that we could see on the Azure portal. Of course, for demo purposes, that's okay. But normally, if we have a script that, for instance, looks up something and gives back a value, then that value is needed for something, maybe as an input to deploy another resource inside our code. And then, of course, deployment scripts can be used to look up values or to execute things, and then we can definitely configure return data that is then returned and can be used in some other ARM template resources. Now, depending on the language you're using, so depending on if you're using PowerShell or Bash using Azure CLI, this works a little bit different. So using PowerShell, you have to use this common variable that, well, that deployment script outputs. You give it a name, in this case it's foo, and then you just assign a value, right, like $something. And if you want to use it later in another resource, for instance, as an input or something, then you just reference to your deployment script resource, reference to outputs, and then reference, in this case, to foo. And then you get that value that has been output by the deployment script. Using the Azure CLI, it's a little bit different. There you have to use an environment variable that actually stores your outputted data. But that works more or less the same way as any other ARM template resource that you're describing. Now, one important question, what happens if you deploy your code more than once? Because that's normally what we do when we have ARM templates and we deploy our code over and over again. Every time we need to somehow extend the configuration of our services, we just redeploy our full ARM template. And because ARM templates are idempotent, that means that only things get changed that need to be changed. So not everything is deleted or touched or something. It's analyzed what actually needs to be changed, and only the appropriate properties are then touched, or new resources are deployed or something. And it's important to understand how deployment scripts actually handle this. And as you can see here, and that's important to understand, is that deployment scripts are not rerun as long as you didn't change the script or any script properties. So that means that they are run, but then once you deploy your ARM template again, they are not rerun, right? So they are only run once. And this is fine, but of course there might be scenarios where you don't want that, right? Where you want to rerun your script from time to time, or maybe even with every single deployment you want to rerun your script. And then you can still do that either by well, changing the script content itself, which well, is okay if you really change your script code. But if you want to rerun the same script over and over again during every single ARM template deployment, then you can use a special property with the name force update tag. And whenever this value changes, the script is rerun, right? And this is what we normally use then. So we just assign the UTC now function, which means that that value will always be set to the current date time. And then, of course, it will change every time we deploy the ARM template. And obviously, the script is rerun all the time. Now, what's also important, if your deployment script after a while gets deleted from the Azure portal, so you just didn't rerun your ARM template deployment, then your deployment script will go away. And then if you deploy your ARM template again afterwards, of course, because ARM doesn't know that this script has already been deployed, it will deploy again, which means that you need to take care how you write your scripts. So your scripts should be written in a way that allow them to rerun. So you might need to add some additional logic to your imperative scripts so that you don't mess up things when they are triggered from an ARM template. All right. So then let's go to the little bit more complex demo, and I think we will also see now how deployment scripts can be triggered that live somewhere else and not in the ARM template itself. Martin.
Thanks. I will try at least to be honest.
You will make it happen.
Yeah, of course. So I'll pull up my screen now, and the thing is inline templates or inline deployment scripts within the template. So I wouldn't recommend, like I said previously, I wouldn't recommend to use that if you have a regular PowerShell or a CLI script that will, it could be like 50 lines of code, and within a double quoted parameter within the template itself, it will get really messy. At least that's my opinion. So referencing an external script might be a better solution. But first, we can take one thing first is the force update tag that Marcel was talking about. So this one will, since this is a demo environment, I want my script to run every time I deploy it, because I have tried this a few times and I want the script to rerun. And what it actually needs to be set in the parameter itself. So you can't set UTC now, for example, directly on the property itself. You need to set it in the parameters of the template file. And I used a few seconds or a few minutes, to be honest, to actually figure that out. So that could be a little bit confusing. So if you if you have a fixed value of a string, for example, within the force update tag, it will not rerun until it is deleted from the platform. Another thing is you can also, like all PowerShell scripts, you can pass in arguments to the scripts. And since it lives within an ARM template itself, you can use parameters that was inputted by the user when they wanted to run this deployment itself, or you can use variables from the template. It doesn't look that sexy, to be honest, but if you take a look here, you can see that I have formatted my arguments to the script. And if I zoom in, it's probably easier to see, but going over here, I am actually running a little bit of the what we have covered in the more complex ARM template live streams that we had. So I am actually using functions within the argument parameter, or what it's called. So I actually wanted to get my storage account key to upload something to the storage account that I am deploying. So I'm referencing the storage account that we deployed within the same template. So it's up here somewhere. I have the storage account. So I'm referencing this one, and I want the storage account key to be passed into my script. Then I can connect to the storage account, and I can upload some files. So also, before we look at the script itself, here again, I can see that we have configured the script or the cleanup preferences and the timeout again. So my timeout, my maximum execution time of the script is set to 5 minutes, and I have set again the cleanup preferences to on success. So the storage account and the container stuff will be deleted, and my script retention interval is set to 1 day. And again, what Marcel said, that you can take outputs from the script. And here I have referenced my my resource, actually, which is an image downloader in this case, which is the script, and then I have the output and the text. So if we go into the script itself, it needs these parameters here to run. So I need a search string, so I can search for myself on Google, which is this script is doing. And then I need the storage container name and the storage account key and the resource group name, so I can connect to the storage account. Then to be able to actually save the outputs, I will need to use a specific variable here. I need to use this deployment script outputs, and I need to declare that before I can add any data to it. So what this script does is what we said in the beginning here, is that we want to use it to run some last mile configuration to our environment. So since we didn't want to create another complex example of resources in Azure, we only had the storage account. So then I used PowerShell, and then we can search for images, and then we can download images and upload them to a storage account. So if we try to run this, or ourselves, and see if we can find some images of him on Google Images. Now I'm actually hoping that we don't find anything
now I'm curious.
Yeah. Okay, so let's see if this if we can see the resources being deployed. It has started the deployment itself, and we are waiting for the resources to be to spin up. And this will, depending on how they load on the region you're in, this will, I've seen this take like 10 seconds, and I've seen it take 10 minutes. So I don't know what your experience is with it, Marcel, but it will take some time to actually provision the resources in some cases.
Correct. Yeah, I have made the same experiences. Yeah.
And also the caching is immense. So it has deployed the storage account, and we are waiting for the script. Or yeah, so it's deployed the script, and now we are this state here, if you can see, is that provisioning state is provisioning resources. So now the deployment script itself is waiting for its resources to be able to run. And we can see everything that we put in as input for the script. So we can see that this was the storage account name, and the key was referenced, and everything that was needed to run. So if you go back and see if it started to, okay, so it was already finished now. We didn't actually see the resources being deployed now either. So let's go back and see if we can catch it. Ah, and it's
gone.
But we can see the output from the script now. So it found a few images of you, Marcel. So it probably will have returned in my code here as well. So uploaded 5 pictures of marcelzehner here now. So if we go in, maybe we can go into the storage account itself and see if it worked.
Oh my God! Don't open the pictures.
Let's see if it actually has some images. I don't know. Ooh, you want me to open any of them?
Yeah.
Yeah.
Pick the first.
There it is. It was small,
All
but
right.
it's probably the preview from the Google image search.
Oh yeah. Oh yeah. Nice.
Okay, I think that was. I'm a little bit irritated that we didn't actually catch the container being spun up, but we did see the output from the script, and if you want me to run it again, so I can try, but or we can summarize the.
Well, I think we've seen the resources in demo 1 already.
Yeah.
So I think that's pretty much okay. It's a cool example how you can actually combine the declarative approach using ARM templates to deploy the storage account, and then have a deployment script that does something like Martin showed to get additional data, for instance, to populate the storage account, which couldn't be done with just regular ARM template resources.
Correct.
So very cool. Thanks, Martin. Okay, so let me go back to my screen. There we go. Good. So we've seen how deployment scripts work, how they can maybe help you out to complete your processes inside ARM templates. So I think it's a great addition to the ARM template show, which adds lots of flexibility to us, because that wasn't possible until now. Until now, you just had to, somehow deploy your ARM templates, and then you had to run some additional scripts later somehow, either manually or through some other process, but it wasn't fully integrated. And now by using deployment scripts, we can actually integrate that. I mean, just as a quick preview for next week, we'll show you a pipelined approach where you could do like, similar things, but of course it's still not fully integrated. The handling between the different parts is much more complex. This is kind of an integrated way. So some key takeaways. I think it's a really cool way to add some imperative logic to your declarative code. As we mentioned, for this last mile configuration, but make sure that you don't use deployment scripts to somehow become faster. So it's not the goal that you can skip developing complex ARM templates and now just do everything with deployment scripts. That's not the idea behind it, because as we've seen, depending on your cleanup preferences, scripts might rerun, might not rerun, and that means that you have to add some logic to your scripts so that they don't fail in both situations, right? So you should still pretty much focus on declarative approaches using ARM templates, and then use deployment scripts where not other possible. All right. Good. So that said, If you want to have a look at Martin's demo, go to this this URL, tinycc/armt repo. There you can get his code and start playing with that specific example that you've just seen. And of course, you also get all the code from the last live streams that are published there. Again, quick look out for next week. Next week, we'll talk about code release using pipelines. Go to this URL to register and get all the details. And then finally, you can again win a swag pack from Microsoft if you promise to visit those 2 links. If you promise to work on your digital badges, then you qualify for a swag pack, and we will draw a winner of today's attendees. And well, if you are the lucky winner, you will get informed by us, and then you will receive your nice swag pack. All right. And that said, I hope it was worth joining today. For me, this was the last task of the day. Not sure about you, Martin, but I'm going home right now.
Apart from family affairs, that will be probably this my last.
Yeah. All right, cool. Same here. So we'll enjoy our time tonight. Hope the same is true for you, and we're looking forward to see you next week, hopefully. Thanks a lot. Thanks, Martin, for the demos, and see you all soon. Thanks. Bye-bye.
Bye.